So here are a few extra examples that we're gonna go over, and we will have gone over in class in case you missed class or you just wanted to go back over them again because you know you've seen it but you can't remember it. And what we're actually proving here is the theorem 2.6 or something like that. Sorry, 2.8. Yeah, 2.8, the vertical angles theorem. That's what we're going to prove here. So here's how it works. I know angle 1 and 3 are vertical angles. Okay, 1 and 3. What I want to prove is that they're congruent. And again, some of you are like, we already said that. Yeah, we did say that earlier, but we didn't prove it. We just said they look congruent. Let's make them congruent. So here's how you actually do it. First of all, angle 1 and angle 3 are vertical angles. Okay. Step 2 is this. Angle 1 and 2 form a linear pair, as do angles 3 and 2. Okay. So angle 1 and angle 2 are a linear pair. And I just say LP because I'm lazy. And angle 2 and angle 3 are a linear pair. And that's just the definition of linear pair. Okay. And again, I know this is sloppy, but this is supplemental. So if you can't read it, come in and ask me. I'll go through it with you. Now you might say, Mr. Moyer, why do we care that they're a linear pair? Well, I say to you, what do we know about linear pairs? Oh, we know that angle 1 and angle 2 are supplements, and that angle 2 and angle 3 are supplements. Why do I know that? Well, the supplements theorem in our textbook says, oh, if you're a linear pair, you're supplementary. So that's the supplements theorem. And now step 4, I'm done. And again, you might say, Mr. Moyer, how do you know you're done? Well, I had a theorem right before theorem 2.8, theorem 2.6, that said angles supplementary to the same angle or two congruent angles are congruent. More importantly, if two angles are supplements to the same angle, which they are, angle 1 and 3 are supplements to angle 2, then angles 1 and 3 are congruent. Sorry, I just been staring at this and I just jumped back here. Angle 1 and 3 are congruent to, are supplementary to angle 2, so angle 1 is congruent to angle 3 by the congruent supplements theorem. Okay. All right. So, yeah, that's the proof. That's how we know for sure vertical angles are congruent. Okay. Next one. This is important because this is like a good semester exam example and a good just general like ACT style question. Solve for x. So we have to identify in this problem is what kind of angles are those two angles? Well, these angles are vertical angles. So we spent all the time in the definition. What do we know about vertical angles? Oh, vertical angles are congruent. So 120 has to equal 2x plus 40. Subtract 40. 80 is 2x. Divide by 2. 40 is x. Another one. Another kind of pretty common example you need to be able to do. This guy here. Another pair of angles in a drawing. This time though, the angles aren't across from each other, they're adjacent. Hey, not only are they adjacent, but they also form a line. So what are they? A linear pair. What do we know about linear pairs? They're supplementary. So we know that 3x plus 10 plus x minus 30 has to equal 180 degrees. And now we add our like terms. 3x and x are 4x. 10 and negative 30 is negative 20. Add 20. 4x is 200. Divide by 4. X equals 50. Anyway, we're just solving for x here. We're not doing anything else. All right. Now, the last problem I want to go over for this, and we went through a lot more in class, and if you did miss class or you're confused, come in. This is just something to kind of be a quick refresher. this problem, not so much this specific one, but this process is something we're going to need for chapter 3. Okay, so we're going to be given that angle 6 is congruent to angle 7. What we have to show is that angle 5 is congruent to angle 8. Now hopefully looking at this, it looks like they are congruent. I mean, hopefully it's, I don't want to say it's obvious, but like, yeah, 5 looks like it's the same as 8. The question is, how do I state that? Well, here's always kind of your hint to think of this. Ignore the proof for a moment. I know I got to get to that. But all I've talked about so far are angles 6 and 7. I need to somehow bring in 5 and 8. Do I have any way to do that? Well, here's where we look at the problem. Where's 5 at? 5 is across from 6. Hey, wait a second. What kind of angle pair are 5 and 6? They are vertical angles. Same thing for 7 and 8. Hey, those guys are vertical angles. And more importantly, I know I can bring 7 and 8 in if I talk about vertical angles, but what is it that I know about vertical? Vertical angles are congruent. Now all 4 of them are congruent. Okay, so now we can just use transitivity to get there. So this is a pretty simple proof once you make that jump, but again, you've also got to know all those things. So 1, given angle 6 is congruent to angle 7, given. 2, we can do this in one step here. Angle 5 is congruent to angle 6. Angle 7 is congruent to angle 8. That's the vertical angles theorem, or you can say vertical angles are congruent. And now this is the part where most people get tripped up at. I mean, once you know this part of it, this is really people, they just get tripped up and get caught. And what it is that I can't just say 5 is directly congruent to 8. What I know is that I know that 5 is congruent to 6 and 6 is congruent to 7. So I can use angle 6 to get 5 and 7 congruent by the transitive property. Okay. And then once I've said that 5 is congruent to 7, I know 7 is congruent to 8. Well, how do I know that? Well, if they're both congruent to 7, they'd be congruent to each other. So angle 5 is congruent to angle 8 by, again, the transitive property. And that's it. Okay. It'd be really nice if there was like some kind of double transitive property. There isn't. It works between 3 things, not 5 or 4. So if you have any questions and this doesn't make sense, come on in. If it does make sense, good. And I'll see you in class. Thanks.